Today I want to talk you through how artificial works. Let's say you have an instrument that you want to connect to artificial. Typically that instrument has an instrument PC next to it that's running some kind of instrument control software. To connect the instrument to artificial, we need a REST API. Sometimes the instrument software exposes a REST API natively. Other times we need to install a special driver on the instrument PC to expose that REST API to us. Either way, that REST API is typically only available from inside a secure network environment, whereas most of artificial systems run in the cloud. To access that REST API, we'll work with you or your IT department to install an industrial PC, or IPC, in that secure network environment that can connect to both the REST API and your artificial instance. The code that makes and manages those connections is called an adapter. The adapter gets built into a container image that is deployed and run on that IPC. Obviously, most labs don't have a single instrument. They have multiple instruments and other resources. Within the adapter, each of those resources are represented as action modules. Within each action module are a number of actions that represent the actions that could be taken on that resource. For example, a liquid handler might have an action called run protocol, whereas a LIMS might have an action called upload results. These actions are the building blocks used to build workflows. Let's pause here for a moment and talk about the workflow lifecycle. Workflows are our way of defining the set of work that needs to be done across the instruments, people, and other systems in your lab. Workflows are written in a subset of Python called orchestration Python, compiled into a program graph and published up to the artificial cloud. When a workflow is run, it gets ingested by our scheduler and integrated into the overall schedule for the lab. The scheduler also monitors and updates the schedule to keep your lab running optimally. The executor looks at what actions are coming up next in the schedule and dispatches them to the appropriate action module, which in turn communicates through the REST API to actually control the instrument. Once action A is finished running, the executor will dispatch action B, and then action C, and so on. The executor can also trigger an assistant, our integrated digital SOP solution, which would send out a notification to call a person into the lab and then walk them through the specific steps that need to be done to complete that action. And of course, during execution, each action module is sending information back to the data record, including job status, instrument status, parameters, and scientific results. This is how artificial works in production. To make things faster and safer during development, you can also run the adapter directly in your development environment, rather than on the IPC, and run workflows on simulated instruments. Let's see how all this works in practice. Here's our example lab. The lab has one liquid handler, in this case a TCAN Evo, but this could be anything since we're an open platform. And the lab also has a LIMS system. Our example workflow is just to load some samples onto the liquid handler, run a protocol on the liquid handler, and then upload some results back to the LIMS. And here it is in orchestration Python. You can see the workflow definition is just a Python function. We can add parameters to the function if we want, but we don't need them for this workflow. Each action in the workflow is represented as a function call in the workflow body. Again, we could add more complex control flow with loops and branches here, but we don't need to for this workflow. Now let's look at how I, as a developer, can connect these resources to artificial and deploy and run this workflow in my lab. Here's what an artificial project looks like as a developer. The project is stored in a GitHub repository, and we're editing it from a GitHub codespace. We publish our toolchain through a dev container and recommend developing artificial projects inside GitHub codespaces to make toolchain management easier. Okay, you can see these files and folders on the left. The workflow code that we just saw will go into the workflow folder, and you can see that here. Remember, workflows get compiled and published up to the artificial cloud to be run, processed by the scheduler, and executed by the executor. The adapter folder contains the adapter code, which again handles the communication between artificial cloud services and the resources in your lab. This code gets built into that container and either run in this code space during development or deployed to the artificial IPC in production. The config folder contains files that define which instance this project will be deployed to, as well as the configuration for the adapter itself. Let's take a look at the adapter first. In our actions file, you can see the action modules I've written to communicate to the liquid handler and the LIMS. Obviously, these are just stubs for now. Each action module is just a class, and each action is just an instance method on that class. Because this code runs on a full Python runtime, we can install any dependencies we want from pip, make network calls, or anything else you might expect to be able to do in a Python script. The only real limitation is the hardware. So for example, we recommend using cloud-based ML endpoints rather than trying to run or train a model on a code space or on the IPC. In production, these actions would be calling out to a REST API exposed by the instrument software or the artificial driver running on the instrument PC. If I want to run the adapter in this code space, I just come over here to the Run Debug tab and click Run up here. I can see the logs here as the adapter is starting up, and now it's registered with the artificial instance to receive action calls. So now if I come over to my instance, I can see that this green check mark indicates that the adapter is running and connected. In production, this would be running on the IPC inside your secure network space, but being able to quickly make edits, restart, see the logs, set breakpoints, etc. makes debugging much faster. Now let's take a look at the workflow. Here's that same workflow code we were looking at earlier, but in our repository. Remember, this code is orchestration Python, so it doesn't actually run in a full Python runtime. It gets compiled to a workflow graph and ingested by the scheduler and executor. We can't install dependencies here, so as a general guideline, complex tasks, especially those requiring dependencies, should be adapter actions. Workflows are generally more for orchestrating the order, control flow, timing, parameters, and results of those more complicated actions, as well as calling assistants into the lab to do manual work. So when I publish this workflow, you can see it gets compiled and published to the instance. Once that's done, I can run this workflow in my lab. When I run this workflow, its compiled program graph is getting ingested by the scheduler and fit into the existing lab schedule. There's nothing else running in the lab right now, so the executor immediately sees it and starts dispatching the actions. First, the executor calls our assistant. I'll just mark that complete. Now you can see it's running the protocol on the Liquid handler. So the executor saw that action call and routed it to the appropriate action module in our adapter. And sure enough, we can see in the logs here that this action is running in our adapter's Python runtime in this code space. This action also sends the instrument status back up to the digital twin and marks it as running for the duration of the action. Once that's done, the executor moves on to the next action. And again, if we look at the logs, we can see that it has been routed to the appropriate action module and is running in our adapter in this code space. And of course, each action is automatically recording its parameters and outputs, so we have a complete end-to-end record of the entire process of running the workflow. This is just a peek into how Artificial works and what the development flow is like. Obviously, there's a lot more going on under the hood. If you'd like to learn more or schedule a demo, please don't hesitate to get in touch.